Hai semua, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Okay, so in this video, we are going to discuss on the topic on inverse Laplace transform using second shift theorem. Okay, so in the previous video, we had learned about the second shift theorem and how to implement the second shift theorem in order to evaluate the Laplace transform, right? But in this video, we are going to see on how to evaluate the inverse Laplace transform based on the same theorem. Okay, so basically, you know that the Laplace transform of the function that shifted by a and multiplied with the step function is equal to exponent negative as multiplied with fs, right? So the inverse Laplace transform of this function is equivalent to this. Okay, so for example, okay, let's say you have this kind of function, okay, where your function has a multiplication with the function of exponent negative s. So here also you have exponent negative 3s. So how to solve the inverse Laplace transform for this function? You can apply the second shift theorem. Okay, so let's have a look on the step-by-step on how to find the inverse Laplace transform. Okay, example, you want to find the inverse Laplace transform for this function using the second shift theorem. Okay, so step number 1, you need to determine the value of a. Okay, so in this case, the a is negative 1. Sorry, a is equal to 1 and a is equal to 3, right? And then, after you determine the value of a, you need to write down the function of fs. Okay, so based on this, you need to determine, so this function is equivalent to exponent negative as fs. So you need to determine what is the function of fs. So in this case, maybe 3 over s, and in this case, is 4 over s squared, right? And then after you write down the function of s, you need to evaluate the inverse Laplace transform for this fs in order to get ft. Alright, so once you get ft, you need to change the variable of t from t into t minus a. Right, and then once you get the function in terms of t minus a, and then finally you can evaluate the inverse Laplace transform of this function using the theorem. Alright, okay, so let's have a look at the example on how to implement all these steps. Okay, for example, evaluate the inverse Laplace transform for the following expression by using the second shift theorem. Okay, so this is the second shift theorem. Write your answer in the form of step function and sketch its graph. Okay, meaning that your final answer must be equal to ft is equal to white number, and then in terms of step function. So you must have something multiplied with ht minus something. Alright. Okay, so this is the function that you need to evaluate. Alright, so we go step by step. Okay, in order to find the inverse Laplace transform of this function, you can apply the linearity concept. So from here you have 2 inverse Laplace transform of 1 over s minus 3 inverse Laplace transform of exponent negative s over s plus 4 inverse Laplace transform of exponent negative 3s over s squared. Okay, so in order to evaluate this, you can just refer to your table of Laplace transform. So for case a over s, so your ft is equal to a. So in this case, a is 1. So here you have to multiply with 1, so equal to 2. Okay, so in order to solve this and this, you may apply the second shift theorem. Okay, so the step by step, usually we can do it in terms of table. For this function, exponent negative s over s. Okay, so in this one, step number 1, you need to determine the value of a, right? So a is 1, and then you need to determine what is the fs. So from here, fs is equal to 1 over s. Okay, because from here, the function is exponent negative as multiplied with fs. So fs is equal to 1 over s. Okay, and then based on this fs, you need to evaluate the inverse Laplace transform to get what is the value of ft. So 1 over s is equal to 1. So that's why ft is equal to 1. So, and then you need to rearrange the t become t minus a. So here, because you don't have t, so ft minus a also 1. And then finally, you can just substitute the theorem. Sorry, you just need to substitute the second shift theorem. So inverse Laplace transform of exponent negative s over s equal to ft minus a ht minus a. So in this case, ft minus a is 1 multiplied with ht minus 1. Okay, so we go to the next function. So here you have exponent negative 3s over s squared. Okay, so in this function, your a is equal to 3 right? So your fs is equal to 1 over s squared. Okay, and then you need to evaluate the inverse Laplace transform for this in order to get ft. So you refer to here 1 over s squared. So n is equal to 2 minus 1. So you have t, right? So ft equal to t. And then you need to change the variable of t into t minus a. So here I have t minus 3 because a is 3. Okay, so finally I can just use this, substitute into the formula. So inverse Laplace transform of this function is equal to t minus 3 multiplied with h t minus 3. Okay, so we can substitute the answer for this and this into here. Alright, so finally the inverse Laplace transform of this function is given by, from here you have 2 minus 3 h t minus 1 plus 4 t minus 3 h t minus 3. Okay, so this is the function that you get based on this fs. Alright, okay, so next we need to sketch the graph. Okay, so now the output of the inverse Laplace transform is in terms of unit step function. So before we can sketch the graph, we need to change the function from unit step function into step function. Okay, because once you find the value of g1, g2, g3, a and b, then only you can sketch the graph. So how to find this value? You just compare this function with this formula. Alright, so based on the comparison, what I have, g1 is equal to 2, right? So g2 minus g1 is equal to negative 3. Okay, so g2 is equal to negative 3 plus g1. g1 is 2. So finally, I have negative 1. Okay, so g3 minus g2 is equal to 4 multiplied with t minus 3. Okay, so g3 is equal to 4t minus 12 plus negative 1. So is equal to 4t minus 13. Alright, so a is equal to 1, b is equal to 3. Alright, and then finally this is how the function in step function looks like. So based on the step function, we can draw the draw the graph, right? So from t0 until 1, okay, so the function is 2. Okay, so now you have 2. From 1 until 3, the function is negative 1. Okay, and then from 3 onwards, the function is given by 4t minus 13. Alright. Okay, so now let's have a look at one more example on how to evaluate the inverse Laplace transform using the second shift theorem. And then we need to write the answer in terms of step function and sketch the graph. Okay, so basically from the question, the function here is given by exponent negative 5s multiplied with 1 plus 2s over s squared. So by using the theorem of linearity, you can split this equation into two so that you have inverse Laplace transform of function exponent negative 5s multiplied with 1 over s squared, okay, here, plus inverse Laplace transform of exponent negative 5s multiplied with 2s over s squared. Okay, so and then this s and s squared I can cancel. So I have 2 inverse Laplace transform exponent negative 5s over s. Okay, so once I have the function that I want to evaluate the inverse Laplace transform in terms of exponent negative as multiplied with any function of fs like this, so I can just apply the second shift theorem. Okay, so in order to apply the step-by-step on how to use the second shift theorem, it's better to you to come up with this kind of table. Okay, so we do one by one for this function and for this function. Okay, so for exponent negative 5s over s squared, so in this case a is equal to 5 and then fs is equal to 1 over s squared. So inverse Laplace transform for 1 over s squared you refer to here. So in this case n is equal to 1. So your ft is t. And then from ft you need to rewrite it as a ft minus a. So you have t minus 5 because a is equal to 5. And then finally, once you have this function, you can just use straight away the formula. So inverse Laplace transform of this function is equal to ft minus a ht minus a. So ft minus a is t minus 5 dot ht minus 5. Alright. Next, we go to the next function. So in this case, a is equal to 5. Fs is equal to 1 over s. So refer to this table. So if fs is equal to 1 over s, so ft is equal to 1, right? And then ft minus a is equal to 1. So finally, I can just use this formula. So ft minus a is 1 dot ht minus 5. Alright, so this is the answer of the inverse Laplace transform of this and inverse Laplace transform of this function. Okay, so finally, the final answer is given by t minus 5 dot ht minus 5 plus 2 ht minus 5. Okay, so here I have a negative 5 ht minus 5, here plus 2 ht minus 5. So finally, I have t minus 3 ht minus 5. Okay, so this is the output of the inverse Laplace transform in terms of unit step function. And then now I need to change it into the form of step function. Alright. In order to change the function from unit step function to step function, we just need to compare this equation with this equation so that we can find what is the value of G1, G2, and A. So from the comparison, G1 is equal to 0 because you don't have anything in the front. Okay, and then G2 minus G1 is t minus 3. So because of G1 is 0, so G2 is t minus 3. Okay, so A in this case is equal to 5. Alright, okay, so finally I can rewrite my equation in terms of step function. Okay, so G1 is 0 and G2 is t minus 3, and then A is 5. Right, so based on the function, you can draw the graph. Okay, so from t equal to 0 until 5, the function is 0, right? And then from 5 onwards, we have the function of t minus 3. Okay, so that's all for now. Thank you for watching. Bye.